Hey everyone, welcome to 7.5 partial fractions. This is a way to integrate things that we normally couldn't integrate. And it's more of a procedure than it is a big idea, so there's not a lot of notes on this, just a couple examples. Take a look at this. Normally, we would try to do a u substitution and say that u is equal to x squared minus 2x minus 3, which makes du 2x minus 2. But there's no way to rewrite that to make it 2x minus 2. So we can't do this as a u substitution problem. What if there was a way to write this as two separate problems? Well, back when I had you for Algebra 2, I taught you how to factor. So I'm going to say that 5x minus 3 over x squared minus 2x minus 3, the original problem, is equal to something over x minus 3 plus something else over x plus 1. Okay? Now if I could find those something else's, those a's and those b's, this is a pretty easy problem. Let's rewrite this as one fraction, x minus 3 and x plus 1. The a needs an x plus 1. The b needs an x minus 3. And on this side, we've got 5x minus 3 over x squared minus 2x minus 3. Well, because both of these denominators are really the same thing, I'm going to cancel them out. So my problem is now 5x minus 3 equals ax plus bx plus a minus 3b. Make sure you understand how I did that. Ax, bx, a minus 3b. Take a look at this part right here. These are the things with x's in them. So I have an a plus b. Those are the x things. Over here, 5 is the x thing. What about the non-x things? These two things don't have x's with them. A minus 3b. Over here, this doesn't have an x with it. Equals negative 3. Now I have two problems and two variables. I can solve this. Solve for one of the variables. In mine, I'm going to say that a equals 5 minus b. And let's plug it in up here. 5 minus b minus 3b equals negative 3. That means that negative 4b equals negative 8, or b equals 2. Plug it in back here, and I find that a equals 3. Now I haven't actually integrated anything, but remember what I was trying to do. I was trying to take this problem that I could not integrate and turn it into this problem, which I could. So now I know my a is 3 over, the a was originally over x minus 3, plus the b is 2, and the b is over top of x plus 1. And let's integrate this. And to make it easier, I'm going to integrate it as two problems. Because remember, I'm trying to integrate this. I'm going to pull the 3 out to make it a lot easier. That's 1 over x minus 3. What's the integral of 1 over something? It's natural log. Absolute value, because natural log can't be negative. Plus, I'm going to pull the 2 out. 1 over something is natural log of something. X plus 1 plus c. And you'll find that most of these have natural log in the answer. So let's take a look at what we did again. I couldn't do u substitution. So I factored the bottom, and I wrote two different fractions that it could be. I cross-multiplied to get my new numerator, and because the denominators were the same, they cancel out. So 5x minus 3 equals, I multiplied the top out. I took the coefficients with x and set it equal to the coefficient with x. I took the regular numbers and set them equal to the regular number. They gave me two equations and two variables. I solved for my two variables, and I plugged them back into the two fractions that I needed. Once I had the two fractions, I integrated each one, and that's partial fractions. Let's take a look at this. What if I have a problem where the top is bigger than the bottom degree? Well, I'm going to divide it. X squared minus 2x minus 3 divided into 2x cubed minus 4x squared minus x minus 3. It's been a long time since you've done long division, but 2x cubed divided by x squared is 2x. That gives me a 2x cubed minus 4x squared minus 6x. If you divide that out, or subtract that now, cancel, I get a 5x minus 3. So my remainder is 5x minus 3 over top of x squared minus 2x minus 3. So now my integration problem is the integral of 2x plus dx, don't forget your dx, plus the integral of 5x minus 3 over x squared minus 2x minus 3. So let's take a look at what we have now. This is really easy. This is x squared. This is the partial fraction we just did. We just did this problem, so I'm not going to do it again. But I can put my answers together. It's x squared plus the answer from before. 3 natural log of x minus 3 plus 2 natural log of x plus 1 plus c. So, this one, when the top is bigger than the bottom, divide it out. Whatever's left over might be a partial fraction. And again, the reason I didn't do this one is it's the same problem we just did. So that's partial fractions. If you have any questions, come talk to me.